Hi, this is Mrs. Parada, and today I'm going to talk about scientific notation. These notes can be found on page 20 of your Pre-Algebra Quarter 1 notebook. So what is scientific notation? Scientific notation is a way to take numbers written in standard form, basically that everyday way you see numbers, and put them into a more convenient way to write them. So if I look at this number, 5,200,000,000,000, there's a lot of zeros to write. It is a little more convenient to write that number this way, 5.2 times 10 to the 12. That is why we use scientific notation. So numbers written in scientific notation are made up of three parts: the coefficient, the base, and the exponent. And scientific notation is a product of two numbers, this coefficient and the base with the exponent. So let's look at the coefficient. That first number must always be greater than 1 and less than 10. So I might see 1.0 all the way to maybe 9.99. I will never see a 10, and I'm never going to see 0.3 or anything less than 1. The base is always 10 in scientific notation. This number will never be any other number than 10. But the exponent will show how many places a decimal moves when you convert a number from scientific notation to standard form. So if I have a positive exponent, that indicates, if my number is in scientific notation, that the decimal will move right. The decimal moves to the right. And with positive exponents, I'm going to see a big number. With negative exponents, my decimal will move left. So the opposite way. And that is when I see small numbers. And I put those two words, big and small, in quotations because, quite frankly, sometimes, as you can see, 128, not such a big number, right? So let's take a little look at how to do these things. I want to write 34,000 in scientific notation. The first thing I'm going to think about is that is a big number, right? So I am going to end up with a positive exponent. Now I need to move my decimal, and a decimal in a whole number is always right here at the end, so that I can get a number between 1 and 10. So if I move my decimal here, well, I still have 3,400. If I move my decimal here, I still have 340. If I move it here, my number is 34. That's definitely bigger than 10. So I'm going to move it here, and lo and behold, I get 3.4. 3.4 is between 1 and 10. Now how many, I got to put my multiplication symbol, places did I move? I moved my decimal 1, 2, 3, 4 spaces. So that is going to be my exponent. Remember, that base is always 10, and it's positive because it's a bigger number. So 34,000 written in scientific notation is 3.4 times 10 to the 4th. When I look at my next example, this is a decimal. It's all the way in this place value. So that is definitely a small number. So my exponent is going to be negative. I'm going to abbreviate that so it fits. So let's move the decimal so I can get it into a number between 1 and 10. I'm going to move it 1 spaces, nope. 2 spaces, nope. 3 spaces, not ready yet. Now if I move the decimal here, right, I have 0.8. 0.8 is less than 1, so I still need to move it 1 more space. And it's going to be after the 8. And because I have moved it after the 8 and there's nothing left, I can just put 8 as my number. 8 is between 1 and 10. I've moved that number enough. That is 8 times, let's see how many spaces. 1, 2, 3, 4, 5, 6, 7. And remember, it's a small number. So I'm going to make it -7. So my number is 8.7 times 10 to the -7. My final number is 128. And again, this is not a huge number, and I have to admit to you, I would never write this in scientific notation, but we will call it a quote unquote, air quote, big number, and that tells me positive exponent. Where do exponents go with whole numbers? Remember, right here. And I'm looking to move that decimal so I get a number between 1 and 10. Not there. That number is 12.8. Ah, here we go. Now I have 1.28. That is in between 1 and 10. Times 10, that's always my base, and I've moved 1, 2 spaces. So 128 could be written, quite frankly, less conveniently as 1.28 times 10 to the second. Sometimes you'll be asked to take numbers written in scientific notation and put them into standard notation. In this case, looking at those exponents is going to give you a good feel to which way does that decimal move. This is a positive exponent. So I should look for a big number. So I'm going to move right. Big. So if I have 2.9, I want to move that 6 places. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then I'm going to fill, so the decimal moves from there. I'm going to fill in these circles, little half circles with zeros. So now I have 2, 9, and 1, 2, 3, 4, 5 zeros. And I'll go backwards and put my commas in. I have 2,900,000. So if you have 2.9 times 10 to the 6th, that's 2,900,000. This is a negative exponent. So that means I'm going to go left because I'm looking to get a small number. So because I'm going to go left, I'm going to put my number over here. And I'm going to go 5 spaces. 1, 2, 3, 4, 5. There's where my decimal is there. 4, 5. So I always like to put a 0 before my decimal place. Fill in those zeros. I get 1, 2, 3, 4 zeros. 1, 2, 3, 4, 35. So 3.5 times 10 to the -5th in standard form looks like that. Alrighty, let's look at 7 times 10 to the -3. Again, negative. So I go left because I'm looking to make that small. Now when I look at 7, where is the decimal for a whole number? Right here, right after. I'm going to move left 3 spaces. 1, 2, 3. I'm going to fill in the zeros, and I get 0.007, or 7 thousandths. So that is how you go from standard to scientific notation and scientific to standard. You can use scientific notation to compare numbers. In this case, I'm circling the larger number. First, look at the exponents. I see the exponent of 7, and I see the exponent of 6. They are both positive. I'm looking for the larger. Because the exponent 7 is larger, guess what? 2.9 times 10 to the 7th is the larger number. Let's look here. I have the exponent of -2 and -3. Because -2 is greater than -3, 5.2 times 10 to the -2 is larger. And I'll just remind you, this is because 7 is greater than 6. That is how I can use scientific notation exponents to my advantage when comparing numbers. That's it for today. Thanks for listening and have a lovely, amazing day.